Domestic channel. Today we're going to dig into all things polygons. Specifically, we're going to look at some important definitions and investigate a couple of Angle-Sum theorems. A lot of good stuff today, so if you'd like to follow along with me, click on the link in the description for a printable guided notes worksheet, and you can write some things down. Now, first things first, let's talk about what a polygon actually is. So this definition is kind of loaded, but a polygon is a closed plane figure with 3 or more sides, and each of the sides are segments. So kind of break that down a little bit and break it into its parts. So again, it's a closed figure. Closed figure meaning there's no open area, there's a definite interior and a definite exterior. It is a plane figure, meaning two-dimensional. Okay, so it would fit on a flat surface, no three-dimensional figures. It's got 3 or more sides. Whereas the sides must be segments. So that means no rounded edges, no circles, no semicircles, nothing with any squiggles, nothing like that. So a polygon, something like this. Now, when you name a polygon, usually you're going to have some points. Okay, so your vertices are named with letters. If you're asked to name a polygon, you're just going to take those letters, put them in order. You can pick whichever one you want to start with. You can go clockwise, counterclockwise, doesn't really matter. So I could say this is polygon EABCD. EABCD. I can pick, again, any other letter I want to start with, whichever direction I want. I just need to stay in order. Now, we also name polygons based on the number of sides. We actually have names for these things. So usually you're going to be dealing with figures with a small amount of sides, likely 3, 4, 5, 6. But the names for the figures from 3 sides to 12 sides are pretty common. So here's a little movie magic there, snap, and there they are. So you're probably familiar with most of these, but a couple to point out: a 4-sided figure, a quadrilateral. There's lots of different types of quadrilaterals, like squares and parallelograms and trapezoids and things like that. Those are all quadrilaterals, so the general name for those is quadrilateral. 5 and 6, pentagon, hexagon, heptagon for 7. I've also seen that called a septagon before. Octagon, nonagon, decagon, hendecagon for 11, not very common, and then dodecagon for 12. Now, there are names for any of these polygons from 3 sides to 3 million sides if you really wanted to go that far. But for the sake of ease, anything that's more than 12, a lot of times you'll just see it as n-gon, where n is just the number of sides. For example, a 15-sided polygon, you can just call it a 15-gon. Chances are you're not going to have to know what a 3 million-sided polygon is. There is a name for it, but you don't have to know that it's a triicosahexagon. It doesn't matter. Okay, now there's 2 classes of polygons that we call convex and concave. Convex and concave polygons, the 2 different types, are pretty easy to tell the difference between the 2. Just the easiest way that I know to deal with this is cave. You see the word cave and you think it caves in, such as this one right here. The definition of convex and concave. Convex, the definition says if you were to draw a diagonal from one vertex to another, a non-adjacent vertex, anywhere you draw those diagonals, you're always going to be contained inside of the polygon. You're never going to be outside or in the exterior of the polygon. Now, if you did that on a concave, you might stay inside on some, but at some point, eventually, like there, you're going to be outside of the polygon, and that will make that a concave polygon. So if you're drawing diagonals and you end up outside the polygon, you will have a concave polygon. Okay, easy enough. Let's get into some numbers here. Talk about angles. So let's say you're interested in knowing the sum of all the angles inside of a particular polygon. Now we know that every triangle has an interior angle sum of 180 degrees, so a 3-sided polygon, which is a triangle, we know that that's 180 degrees. Now, when we have 4-sided figures and 5-sided figures, is it always 180 degrees? Well, the answer is no. It depends on how many sides you have. Now, how do we know how many degrees, what is the total interior sum of all the angles inside of any given polygon? So here's what we're going to do. We're going to draw all possible diagonals from any given vertex in these figures. So for example, on a four-sided, draw a diagonal from one vertex to any other non-adjacent vertex. That's the only one we get here. If we did the same thing for the pentagon, we can start down here, draw some diagonals to non-adjacent vertices. We do the same thing here. Okay, what we've done is we've broken these things into sets of triangles. Okay, now if you look at these, again, we know that a triangle here is 180 degrees, and there is one triangle in this figure. If we break up the quadrilateral, we end up with two triangles, where the sum of all the angles in this triangle and the sum of all the angles in this triangle really is the total sum of the angles inside of the quadrilateral. So if we add those up, we're going to get the sum of all the angles in the quadrilateral. And notice that there's two triangles in this thing. For the pentagon, we've got three triangles. I'm sure I skipped two there. Three triangles. And then in the six-sided, the hexagon, we've got four triangles. And we could keep going forever and ever, as many sides as we want. Now the deal here is there is a relationship between the number of triangles that I can create in this method and the number of sides that each polygon has. For example, there's one triangle in this figure, there's three sides. Here we have two triangles for four sides, three triangles for five sides, four triangles for six sides. Can you see what the relationship is? It's always two less, two less. So again, six sides, four triangles, five sides, three triangles. If I subtract two from the number of sides, that leaves me with the number of triangles that I can create, where all of those triangles, when I add up all the angles, will get me the sum of all the angles in each figure. Okay, so if we want to make up a little expression here that's going to get me the total sum of all the angles in any given figure, you take the number of sides, so we're going to use n for number of sides, minus 2, which again gets me the number of triangles, and we're going to multiply that by 180 degrees because each triangle will have a sum of 180 degrees. Okay, so number of sides minus 2, take that value times 180. Okay, and this is a special theorem. This is called the triangle Angle-Sum Theorem. Okay, the triangle Angle-Sum Theorem is a way to get the sum of all the angles inside of any polygon as long as I know the number of sides. Okay, so if we extend this out, if I take the number of sides, we'll go with the quadrilateral first. Number of sides is 4. 4 minus 2 is 2. And 2 times 180 is 360 degrees. Okay, so any quadrilateral, the angle sum is always going to be 360 degrees. We can do the same thing for all these. For a five-sided, 5 minus 2 is 3. 3 times 180 is 540. And then finally for the six-sided, the hexagon, 6 minus 2 is 4. And then 4 times 180 is 720. Okay, so plug in the number of sides. Take the number of sides minus 2, multiply that value by 180, and that will get you the total sum of all the angles in any polygon. Okay. So quick example. Let's say that I want to find the total sum of the interior angles in a decagon. So one important thing about your definitions and your keywords here is if you're asked to find the sum of all the angles in a decagon, you have to know how many sides a decagon has, which, if you remember from the chart before, it is a 10-sided figure. So the sum of all the interior angles in a decagon, it's as easy as using your formula, number of sides minus 2 times 180, plugging in the number of sides, decagon is 10, 10 minus 2 times 180 is 8 times 180, and if you multiply 8 times 180, you get 1,440 degrees. Okay, now we can take this one step further if we want to. If we talk about what's called a regular polygon. If you've you've heard that before. A regular polygon, it just means that all the sides and angles in that polygon are congruent to one another. Okay, so let's look real quick at a regular octagon. Now an octagon, you know, that's the stop sign. I'm going to use red here. So a regular octagon, pretend with me for a minute. Oh, I'm so bad at drawing. Pretend with me for a minute that all sides and angles in this thing are congruent. I'm going to try to do a better job to make it look like it's maybe regular. I'm going to go with that. Okay, so a regular octagon. If I want to know the measure of each individual angle in this thing, okay, not the sum per se, but each individual angle, I have to know the sum first. I kind of have to start there. So if I want to get the sum of all the interior angles, I go back to my formula, number of sides minus 2 times 180. I plug in 8 for the number of sides, which gets me 6 times 180, and 6 times 180 is 1080. So that's if I took all 8 of these angles inside of this octagon and added them all together. Now again, this is a regular octagon, meaning all those angles are the same. So if all the angles are the same and all 8 of them add up to 1080, what do I have to do to get each one? Just divide. 1080 divided by the number of angles, which is 8, and that's going to tell me what each individual angle will have to be, and it is 135 degrees. Okay, and again, easy as that for any number of sides. Use your formula, divide by the number of sides. That'll get you the measure of each individual angle. Just don't forget, that only works for regular polygons, only if all the angles and sides are the same. Okay, let's talk about exterior angles. So that formula there is for interior angles, the interior Angle-Sum theorem. Let's talk about exterior angles. Now, what is an exterior angle? It's just an angle that is created when I extend each side. I create exterior angles that form outside of the polygon. So I've got my triangle here. This would be considered an exterior angle. This is an exterior angle. This is an exterior angle. Okay, you're always going to have one exterior angle next to an interior angle. And if you notice, because I have that straight line there, you will have a linear pair. A linear pair of angles, meaning they are supplementary. They add up to 180 degrees because they are on that straight line. That's going to help us out in just a second. Okay, so at each vertex I extend out, I make these exterior angles. Now, if I want to know what the sum of all those angles would have to be, what I'm going to do is I'm going to do a little algebra here. Okay, so I want you to think for a second. If I take the interior and exterior sum, interior, exterior sum, and I subtract from that the interior sum, what I'm going to have left is the exterior sum. Okay, so follow along here. If I take the interior and exterior angles together, which I know what that's going to be here in a second, I'll show you, and I subtract out the interior, all that's left over will be the exterior. Okay, you with me? So think about if you have an interior angle right next to an exterior angle, here, here, and here, the sum of each pair has to be 180 degrees. It's a straight line. Okay, so I know that the sum of each interior and exterior angle added together only depends on how many vertices I have. So if I have a triangle here, I've got 3. If I had a 5-sided figure, I'd have 5. So it's just n, the number of sides. Okay, so the interior and exterior sum of any polygon added together, it's just going to be the number of sides times 180. Again, each pair of angles here is going to be 180 degrees since they're on a straight line. So 180 degrees times the number of sides will get me the interior and exterior added together. Now if I subtract out the interior, again, what's left is exterior. How do I know what the interior is? We just had a formula. It was that Angle-Sum theorem. So if I take, again, it is the number of sides, I'm going to put this in brackets here, minus 2 times 180. Okay, it's going to look real kind of gnarly for a second, but it'll work itself out. And that's going to get me my exterior. Okay, so again, total interior and exterior, 180 degrees times the number of sides gets me each set, minus the interior, which is that triangle angle sum theorem, number of sides minus 2 times 180, what's left over is going to get me the total of the exterior. So if we do a little bit of algebra here, start inside my brackets, I'm going to distribute out that 180. So I've got 180n minus. Inside my brackets, I've got n times 180. And then 2 times 180, that's 360. So minus 360 equals the exterior. Okay, I'm going to distribute this negative sign into my brackets, which gives me 180n minus negative into 180n is negative 180n, and then negative 360, you can also think of this as negative 1 being distributed. Negative 1 times negative 360 is a positive 360. And you can see here that you're going to get something that cancels out. Those 180n's, 180n minus 180n is nothing. What's left? It's 360. Okay, so your exterior angles, not just with the triangle, but any number of sides, the exterior angles always have a sum of 360. Okay, now that seemed like a lot of work just to get to that final outcome there, but the good news is you don't have to do this every time. You know it. It's 360. Okay, so the sum of your exterior angles, regardless of the polygon, is always 360 degrees. Okay, so that's the exterior angle sum, 360. So let's use that. So a final example. Let's say we want to find the measure of one interior and one exterior angle in a, we'll go a regular 18-gon. So an 18-sided polygon, a regular 18-sided polygon. I want to know the measure of one interior angle and one exterior angle. Now, I'm not going to attempt to draw a regular 18-gon. I can't even do an 8-sided, so let alone an 18-sided. But if I just kind of make just kind of a general looking thing here, so I'm not going to close it, I'm just going to give you an idea of what it may look like. And I'm going to extend out each one of those sides so I can see my interior and exterior angles, what that might look like. And it would go all the way around 18 sides. Okay? Now, if you think about this problem, there's a couple different ways you could go about it. But as always, you know, in math, we're trying to look for the quickest way that's going to get me the right answer. It's going to get me what I'm looking for. So one interior, one exterior. I would recommend always, if you can, start with exterior. And the reason being, regardless of your polygon, it doesn't matter what it is, your exterior angle sum is always 360 every time. Doesn't change. The interior angles do change with the number of sides. Exterior does not. So I always start with exterior first. So if I think about this, if one exterior angle is what I'm after, I already know that all of them added together is going to be 360. How many are there? 18. So if I take 360 degrees, divide that by 18, that's going to tell me what the measure of one exterior angle is going to be. So 360 divided by 18, it's 20 degrees. So one exterior angle in a regular 18-gon is 20 degrees. That's here. 20, 20, 20, 20. All those exterior angles are 20. Okay, so now I've got my interior. I could go through and use my interior angle sum theorem and minus 2 times 180, plug it in, divide by 18. I can do that. But there's a shortcut. And the shortcut is the fact that exterior angles and interior angles are linear pairs. They're supplementary right next to each other on a straight line. So that means they always add up to 180 degrees. So my interior and exterior together have to make 180. And what's 180? Minus 20. 160. There it is. Okay, so like most things in math, there's lots of ways you can get to what you're looking for. The more you practice, the more you're going to find the little shortcuts and kind of figure out what's the best way to go about these things. So exterior, if at all possible, it's the easiest way just because that sum never changes. It's always 360. All right, hope you enjoyed today's lesson. It was a little bit of a touch and go there with those poorly drawn polygons, but I think we made it through. If this was helpful for you, feel free to give it a thumbs up, subscribe to the channel, and really the best thing you can do is to share it with somebody else that you think that would find it useful. That's going to help me out a lot. I love making content, and the more subscribers that I get, the better content I will continue to make. So thanks for watching, appreciate it. We'll see you next time.